calculated by the two different method. One is called a scalar or dot product of two vectors. Okay, the first one is a scalar or dot product of two vectors, and second one is vector or cross product of two vectors. Okay, so two separate exercises are based on, one exercise is based on the scalar or dot product of two vectors, and another exercise is based on cross product. Okay, so the first we will discuss the scalar product. Okay, dot product. First we will discuss the dot products. Okay, so take one by one. So now we are moving to the exercise 10.3, and the exercise 10.3 based on this scalar dot product. So but before going to the exercise of dot product, let me explain what is the meaning of dot products. Okay, so if A and B are two vectors, if A and B are two vectors, then it is written as A dot B, and A dot B is equals to magnitude of A into magnitude of B into theta into cos theta, and where theta, this angle is lies in between 0 to pi, 0 to pi, where theta lies in between 0 to pi. Okay, now from this definition we can come to the conclusion कि if first case, if vector A is 0 or vector B is 0, now out of two vectors, if vector A is 0 or vector B is 0, then theta is not defined in this case. Why? Because A dot B will be this, the whole result will be 0. So in this case theta will not be defined. Okay, in this case theta will not be defined. Okay, so and theta is not defined in this case, means A dot B. So this means that A dot B should be equal to 0. A dot B is equals to 0. Okay, so if the dot product of two vectors are equal to 0, so this implies that the vector A is perpendicular to vector B and vice versa. Vice versa means that if we have to show that the two vectors are perpendicular, it means we will find the dot product of the two vectors, and if the dot product of the two vectors are 0, then it means the vector A and B are perpendicular. Okay, and if in the question it is given that the two vectors are perpendicular, it means their dot product must be equal to 0. Okay, got it? Now another case, if theta is equals to 0, theta is equals to 0, so put the value of here. So in this case A dot B is equals to magnitude of A into magnitude of B. Why? Because cos 0 and cos 0 is equals to 1. Cos 0 is equals to 1. Okay, in very particular case, A dot A is equals to magnitude of A square. Okay, in this case again theta is 0. So in this also case theta will be 0. Another point is, if theta is equals to pi, means what about the dot product? If A theta is equals to pi, so A dot B is equals to minus magnitude of A into magnitude of B, because cos pi, and cos pi is equals to minus 1. Okay, so in this case, if A dot minus a is equals to, this is equals to minus of magnitude of a square. So in this case again theta will be equal to pi. Okay. Now the another point is, in the same component the dot product I dot I is equals to j dot j is equals to k dot k. So in the same dot product, the product of same component is always equals to 1. I dot a is equals to j dot j is equals to k dot k is equals to 1. And the dot product of the different components, so I dot j or j dot k or k dot I, that is equals to 0. That is equals to 0. Okay. And the another point is, okay, to find the angle between the two vectors, okay, by applying this formula. So this cos theta is equals to a dot b divided by magnitude of a into magnitude of b. Okay. So to find the value angle between these two vectors, then cos theta is equals to a dot b upon magnitude of a into magnitude of b. Okay. And another property the same, that is a dot b. A dot b is same as b dot a. This is this is called commutative property. And distributive property means a dot b plus c. This is by applying the distributive property a dot b and plus a dot c. So this property is called distributive property. Okay. And another property is, if lambda into a dot b vector, okay, any scalar number multiplied with the vector and with dot is b, so this is equal to lambda times a dot b. Okay, lambda times a dot b, or we may write the same as a dot lambda times b. Okay, so these all about this. And another point is, one important point is projection. Projection of vector a on vector b. Okay, to find the projection of vector a on vector b. Okay, so how we will find the projection? So to find the projection of a vector, uh, that is, projection means the projection of a on the vector b, that is equals to a dot b divided by, and the projection on in b, so it should be magnitude of b. Okay, and if the projection is on a, then a dot b upon magnitude of a, right? So these are the basic concepts of this exercise. And now move to the exercise 10.3. Okay. Exercise 10.3. Now we will start again. It's very simple exercise and nothing to be worried. Very simple exercise. All the questions are based on directly these concepts. Okay, so remember these concepts and then we will simplify these all the questions in very simple way. Okay, so exercise number 10.3. So exercise 10.3 is find the angle between the two vectors a and b with the magnitude is root 3 and root 2. Okay, magnitude is given. So we will apply the formula. Question number 1. So the magnitude of this vector a is given root 3 and magnitude of vector b is given 2. Okay, and a dot b is also given A dot B is also given, that is root 6, and find the angle between them. So by applying the formula, cos theta is equals to A dot B upon magnitude of A into magnitude of B. And now put the value. So A dot B is given root over 6, magnitude of A is given root over 3, and this is given 2. So this can be written as, what we can write, root 3 into root 2 upon root 3 into 2. So we can cancel out. Now it is after the cancellation 1 by root 2. So cos theta is equals to 1 by root 2. So what about the theta? Theta is equals to cos, meant it should be pi by 3. Okay, it should be pi by, sorry, it is 1 by root 2, so it should be pi by 4. No, I think it is 1 by 2, it is 1 by root 2, so it should be pi by 4, because cos 45 degree pi by 4 is equals to 1 by root 2, so theta is equals to pi by 4. So this was the question number 1. Okay, now the second question is, find the angle between of these two vectors. Find the angle between of these two vectors. So let vector A is equals to I cap minus 2j cap plus 3k cap, and vector B is equals to 3i cap minus 2j cap and plus k cap. Okay, we have to find the angle between these two vectors. So as per the formula, cos theta is equals to A dot B upon magnitude of A into magnitude of B. So find the magnitude of A first. So magnitude of A means 1 plus minus 2a square 4 plus 3a square 9. So this is root over 14, and magnitude of B is equals to 3a square 9 plus minus 2a square 4 and plus 1. So again it is coming root over 14, and then apply the formula. A cos theta is equals to A dot B upon magnitude of A into magnitude of B. So A dot B means I minus 2j plus 3k and dot 3i cap minus 2j cap plus k cap, and divided by root over 14 into root over 14, because magnitude of A and B are both are same. And now apply the dot product. Okay, I apply the dot product. So I and I, 1 3 is a 3 dot product, because I into I 1, then minus minus plus 4, 2 2 is a 4. Okay, and plus 3 1 is 3, and divided by 3 1 is 3, and divided by, this is 14. So 4 3 7 3 10, 10 by 14, which is equals to 5 by 7. So this here 4 theta, what will be the theta? The theta is equals to cos inverse 5 by 7, because cos theta is 5 by 7. So theta is cos inverse 5 by 7. Okay. Now the next question is question number 3. Find the projection of the vector I minus j on the vector I plus j. So let vector A is equals to I minus j cap, and the vector B is I plus I cap plus j cap, and we have to find the projection A on B. Okay, so the projection of vector A on B is equals to A dot B upon magnitude of B. So A dot B means I minus J dot I plus J, divided by magnitude of B means 1 plus 1. So I 1 ones of 1 and minus 1 upon root over 2, that is equals to 0 by root 2, that is equals to 0. So hence the projection is 0. Okay. And now the next question, again the same question, find the projection of vector I plus 3j plus 7k on this vector. So this I am leaving for your, okay, suppose this let vector A vector is I cap plus 3j cap plus 7k cap, and vector suppose B is 7i cap minus j cap plus 8k cap, and we have to find the projection A on B. So apply the formula, projection of A on B is equals to A dot B upon magnitude of B. Okay, so you will complete yourself. Now I am moving to question number 5. Question number 5. Question number 5th. And the 5th question is, show that each of the three vector is a unit vector. And what are the vectors? And the vectors are, let vector A is equals to 1 by 7 2i cap plus 3j cap plus 6k cap. This is A vector I have supposed, and vector B is equals to 1 by 7, and this is 3i cap minus 6j cap and plus 2k cap, and C vector is equals to 1 by 7, and this is 6i cap plus 2j cap minus 3k cap, and we have to show that, as per the question, we have to show that they are mutually perpendicular to each other. It means we will find A dot B and it should be equal to 0. Then we will find B dot C, their dot product should be 0. And then we will find C dot A, mutually perpendicular, A, B and C. Okay. So find we have to show that as a unit vector, we have to show that. So first we have to show the unit vector, then product. So for the unit vector, find the magnitude of A vector. So this is 2 by 7 square, 2 by 7 square, and plus 3 by 7 square, and plus 6 by 7 square. Okay. So this is equals to 4 by 49 and 9 by 49 and 36 by 49. So this is 36 for 40, 49 by 49. That is equals to 1. And magnitude of this B, this is root over 3 by 7 square and plus 6 by 7 square minus 6 by 7 square we will write, and plus 2 by 7 square. Okay, so now it will be 9 by 49 and then 36 by 49 and then 4 by 49. So 36 for 40, 49 by 49, again it will be 1. And then C, magnitude of C, so it is root over of 6 by 7 square and 2 by 7 square and plus minus 3 by 7 square. So this is equals to again 36 by 49 and plus 4 by 49 and plus 9 by 49, and again it is coming 49 by 49, so that is 1. So in all three cases the magnitude of A, B, C are equal to 1. So therefore each vector is a unit vector. So this implies that vector A and vector B and vector C are unit vectors. So this was the first part of this question. And now the second part is we have to also show that they are mutually perpendicular to each other. So we will find A dot B. So A dot B means 2 by 7 I cap plus 3 by 7 J cap plus 6 by 7 K cap. Okay, and dot B 3 by 7 I cap minus 6 by 7 J cap plus 2 by 7 K cap, and find the dot product. So that is equals to 6 by 49 and then minus 18 by 49. Okay, and then plus 12 by 49, 12 by 49, 12 by 49. So 12 plus 6, 18 by 49 and minus 18 by 49, that is equals to 0. So this implies that vector A is perpendicular to vector B. Okay. Similarly, find B dot C. So B dot C means the B vector is 3 by 7 I cap minus 6 by 7 j cap and plus 2 by 7 k cap, okay, dot c vector, that is 6 by 7 I cap plus 2 by 7 j cap minus 3 by 7 k cap, and apply the dot product. So this is 18 by 49 and minus 6 to the 12 by 49 and then minus 6 by 49. Okay, so 12 minus 6, 18 plus 18, so again it will be 0. So this implies that vector B is perpendicular to vector C. Okay, now we will find C dot A. C dot A. So vector C is equals to 6 by 7, 6 by 7 I cap plus 2 by 7 j cap minus 3 by 7 k cap and dot C dot A. So this is 2 by 7 I cap plus 3 by 7 j cap and plus 6 by 7 k cap, and find the dot product. 6 to the 12 by 49 and plus 2 3 is 6 by 49 and minus 6 3 is 18 by 49. So again it is coming 0. So this implies that C is perpendicular to A vector. So finally A is perpendicular to B is perpendicular to C. Okay, so they are mutually perpendicular. This we have to show. Okay, now move to question number 6. The question number 6. And the question number 6 is find magnitude of A and B if what is given A plus B dot A minus B is equals to 8. Okay, and magnitude of A is equals to magnitude of A is equals to 8 times magnitude of B. This also relation is given. So first apply the dot product. A dot A means A dot A plus minus minus A dot B and plus B dot A and minus B dot B. This is equals to 8. So this A dot B plus minus it will be cancel. So this is magnitude of A square minus magnitude of B square is equals to 8. And the value of magnitude of A is given. So this is 8 times magnitude of B, okay, whole square, and minus magnitude of B whole square is equals to 8. So 64, and magnitude of B square minus magnitude of B square is equals to 8. So it should be 63. Magnitude of B square is equals to 8. So magnitude of B square is equals to 8 by 63. So therefore magnitude of B is equals to root over of 8 by 63. Okay, and 8 by 63 means 2 root 2, 2 root 2, and 9 7 is 63, so 3 root 7. So this is the value of magnitude of B. And now put the value of magnitude of B here. So therefore magnitude of A is equals to 8 times magnitude of B, and the magnitude of B is equals to 2 root 2 upon 3 root 7. So this is equals to 8 to the 16 root 2 upon 3 root 7. So in this way we have find the value of magnitude of A and magnitude of B. Okay. Okay. Now move to next question. Question number 7. Question number 7. And the seventh question is again. So what we are observing, all the questions are directly based on the basic concepts. So if you remember the basic concepts, then all the questions, solution of all the questions are very simple. Okay, are you getting my point? Okay. Now the next question is question number 7th. And the seventh question is evaluate the product 3a vector minus 5b vector dot 2a vector 2a vector plus 7b vector. So in between the two vectors, the dot is given. So apply the dot product. So this is 3a dot 2a plus 3a dot 7b and minus 5b into dot 2a and minus plus minus 5b dot 7b. So this is 6a square, magnitude of a square, and this is 21 a dot b, right? 7 3 the 21, and this is minus 5 to the 10 b dot a, okay, and minus 35 magnitude of b square, okay. And as we know that a dot b is same as b dot a, so the final answer should be 6 times magnitude of a square and 21 minus 10, that is 11, plus 11 a dot b and minus 35 magnitude of b square, and this is the final answer of this question. Okay. Now the next question is question number 8, and the eighth question is find the magnitude of two vectors a and b having the same magnitude and such that the angle between them is 60 degree and their scalar product is 1 by 2, right? So what is given? Okay, let a and b are two vectors. Okay, a and b are two vectors. So according to question, the question says magnitude of A is equals to magnitude of B. In the question, it is given that okay, two vectors A and B having the same magnitude and such that the angle between them, okay, angle between them is 60 degree. So, and their dot product, a scalar product, means A dot B is given 1 by 2. This is given. So apply the formula. Okay, cos theta is equals to A dot B upon magnitude of A into magnitude of B. This is the formula. So by the cross multiplication, uh, this implies that A dot B is equals to A dot B is equals to, or do one thing. Okay, cos theta is given 60 degrees, so directly we can put here. So cos 60 degree, okay, and A dot B is given 1 by 2, and this is magnitude of A and magnitude of B both are equal. So can we write magnitude of A square, and the value of cos 60 is equals to 1 by 2, okay, and this is equals to 1 by 2 into 1 by 2 divided by magnitude of A square. So that is equals to, this implies that magnitude of A square is equals to 1. So therefore magnitude of A is 1. So that is equals to magnitude of B. Because as per the given question, K, A and B are having the same magnitudes. Okay. Now the next question is question number 9. And the ninth question is question number 9. And the ninth question says find the magnitude of x for the unit vector a, and where it is given x minus a dot x plus a is equals to 12. Okay. So x minus a vector, x minus a vector x minus a vector dot x plus a vector that is given 12. Okay, so apply the dot product first. So x dot x plus x dot a minus a dot x and plus minus minus a dot a is equals to 12. So this is x square and this will be cancelled because x dot a and a dot x both are same thing, and minus magnitude of a square is equals to 12, and it is given that for a unit vector, so it is given that it is 1. So x square minus 1 is equals to 12. You may write reason since it is given that magnitude of a is 1, it is given it is unit vector. So the magnitude of x square is equals to 13. So therefore magnitude of x is equals to root over of 13. Okay. Then the next question is question number 10. And the question number 10 is the a vector is given. A vector is equals to 2i cap plus 2j cap plus 3k cap, and b vector is given minus I cap plus 2j cap plus k cap, and the c vector is given 3i cap plus j cap, 3i cap plus j cap, this is given, are such that a plus lambda times b vector is perpendicular to c vector. This condition is given. Okay, this condition is given. So a plus lambda times b vector means 2i cap. Okay, 2i cap plus 2j cap plus 3k cap plus lambda times b vector, that is minus I cap plus 2j cap plus k cap perpendicular, so dot c, and c vector is given 3i cap plus j cap, and the dot product should be equal to 0 because a plus lambda times b is perpendicular to c vector. So first we simplify this one. So 2i and this is equals to 2 and minus lambda I cap, okay, by taking the I cap as common, and 2j and plus 2 lambda, 2 plus 2 lambda j cap, okay, and 3 plus lambda k cap, okay, dot 3 I cap and plus j cap is equals to 0, and now take the dot product. Okay, so this is 3 into 12 minus lambda with I or with j, 2 plus 2 lambda into 1, that is equals to 0. So finally it is 36 minus 3 lambda and plus 2 lambda is equals to 0. So 36 plus 2, 38 minus lambda is equals to 0. So lambda is coming 38. Lambda is coming 38. So something is wrong. Let me check again. Answer should be 8. 2. Oh, by mistake I have multiplied with 12. So it is 2 minus lambda. It is 2 minus lambda. So I have written wrong here. So 2 minus lambda, 2 minus, so 3 into 2 minus lambda, 3 into 2 minus lambda, and plus 2 lambda is equals to 0. So 6 minus 3 lambda plus 2 and plus 2 lambda is equals to 0. So 6 plus 8 minus lambda is equals to 0. So lambda is equals to 8. This is the answer given in your book. Okay. Now the next question, the question number 11. Question number 11. Okay. So 11th question is question number 11. It is given that show that magnitude of A into B, magnitude of A into B is plus magnitude of magnitude of B into A vector is perpendicular to A into B, magnitude of A into B minus magnitude of B into A. Means are perpendicular, means we have to show that their dot product should be equal to 0. So it means magnitude of A into B plus magnitude of B into A, okay, dot magnitude of A into B and minus magnitude of B into A should be equal to 0. Okay, so find out. So this can be written as by applying the dot product. So this is magnitude of A square and then B dot B, okay, and minus magnitude of A into magnitude of B into B into A, B dot A, okay, and then plus magnitude of B into A and into magnitude of A into B and plus minus magnitude of B square and dot A into A dot A. So this is equals to magnitude of A square and magnitude of B square, and this plus minus it will be cancel, and minus magnitude of B square into magnitude of A square. So this is also cancel. So what is coming? 0. So therefore they are perpendicular. Okay, they are perpendicular. Now the next question is question number 12. And the 12th question number 12. What is given if A 12th question, A dot A is equals to 0, A dot A dot A is equals to 0 and A dot B is equals to 0, then what can be concluded that about the vector B? Okay, so here A dot A is 0, so it means that magnitude of A square is equals to 0. So therefore the magnitude of A is also equal to 0. So when the magnitude of any vector is 0, it means that A vector A is a 0 vector. It is a 0 vector. Okay. So if by satisfying this condition A dot B is 0, so it means that if A is 0 vector, so therefore we can say that B is any non-zero vector. If vector A is 0, then B is any non-zero vector. So this is the conclusion. Okay, we can write. Next question is question number 13. And the 13th question is, if A, B, C are the unit vectors such that A plus B plus C is equals to 0, unit vectors magnitude of A is equals to magnitude of B is equals to magnitude of C, that is equals to 1. It is given, and A plus B plus C whole A plus B plus C is equals to 0. Then we have to find the value of A dot B plus B dot C plus C dot A. Okay. So by applying this identity, since magnitude of A plus B plus C square is equals to, we can write A plus B plus C, okay, dot A plus B plus C. We can write the reason, since magnitude of A square, we can write A dot A, okay, by applying this. So now applying A dot A, so this is A dot A plus A dot B plus A dot C, and then plus B dot A and plus B dot B and plus B dot C, then plus C dot A, okay, and plus C dot B and plus C dot C. So this is A square, magnitude of A square, and A dot B. So we are having A dot B and B dot A and twice, and B A dot C. So plus twice of A dot B plus B dot C plus C dot A, okay, and plus magnitude of B square plus magnitude of C square. And as per the direction of the question, these are the unit vectors. So 1 plus 1 plus 1 plus twice of A dot B plus B dot C and plus C dot A, okay, and A plus B plus C. So this is A plus B plus C is 0. So this will be 0, 0 and 0. So this is minus 3 is equals to twice of A dot B plus B dot C and plus C dot A. Okay. So this is minus 3 by 2 is equals to A dot B plus B dot C and plus C dot A. Okay. So this is the answer of this question number 13. Okay, now the next question is the question number 14th, and the 14th question is, if either vector A is 0 or B is 0, then A dot B is 0, but the converse need not be true. So justify your answer with the example. Okay, so what is given, if A is 0 vector. Now we will take A is non-zero vector. Okay. So if A is equals to, say, 2i cap plus 4j cap plus 3k cap, and the vector B is equals to 3i cap plus 3j cap and minus, say, 6k cap, then find A dot B. So A dot B is equals to 2 3s are 6 plus 4 3s are 12 and minus 6 3s are 18. So 18 minus 18, that is equals to 0. So A dot B is equals to 0. But the magnitude of A is equals to 4 plus 16 and plus 9. Okay, so 625 root over 29, which is not equal to 0. Okay, similarly, so vector B is equals to, and magnitude of B, this will be equal to 9 plus 9 plus 36, that is root over of 45 9 54. So which is again not equal to so 0. So this is not equal to, so 0. So if the question says, okay, if A is 0 vector or B is 0 vector, then A dot B is 0. Okay. But the converse means if the vector A is not equal to 0 and the magnitude of A is not equal to 0, the magnitude of B is not equal to 0, but A dot B should may be equal to 0. So this was the explanation of this question number 14. Okay. Now move to question number 15. Question number 15. Fifteenth question number 15. And the 15th question is, if the vertices ABC is right angle the right of a triangle ABC are 1, 2, 3, minus 1, 0, 0, 1, 2, then find the angle ABC. Find the angle ABC. Okay. So here the vertex A is given. The vertex A is given 1, 2, 3. A vertex. This is vertex A. A vertex is given. A vertex is given, and B vertex is minus 1, 0, 0, and C vertex is, what is C vertex? 0, 1, and 2. Okay. Then find the angle ABC. So angle ABC means we will find BA. Angle BC. Okay. BA, find vector BA. So BA means A minus B. A minus B. A minus B means 1 plus 1. This is 2I cap and plus A minus B, BA. So 2 minus 0 plus 2J cap and plus 3K cap. This is the BA. And now find BC. So BC means C minus B. So 0 minus minus plus 1, that is 1I cap. Okay, 1I cap. And 1 minus 0 means plus J cap and plus 2K cap. This is the value of BC. Okay. So now since BA dot BC is equals to magnitude of BA into magnitude of BC into cos theta, and theta is angle ABC. Okay. So BA dot BC. Now find the dot product or the cos of angle ABC is equals to BA dot BC upon magnitude of BA, magnitude of BA into magnitude of BC, magnitude of BC. So BA dot BC, what about the BA dot BC? This is 2 into 1, 2, and plus 2 and plus 6, and magnitude of BA, find the magnitude of BA. So this is 4 plus 4 and plus 9, that is equals to root over 17, and find the magnitude of BC. So magnitude of BC is equals to 1 plus 1 plus 4, that is root over 6. Now put the value. So this is root over 17 into root over 6. So 2 plus 2, 4, 6, 2, 8 to 10. 10 upon root over of 102s. Okay. So therefore angle ABC is equals to cos inverse 10 upon root over of 102, and this is the answer of this question number 15. Okay. Now the next question is question number 16. The question number 16 is show that the 3 points are collinear. Okay, the 3 points are collinear. We have to show that the 3 points are collinear. So from the given points, we will find the vector first. Question number 16th. And the question number 16th is show that the given points are collinear. Point A is point given 1, 2, 7, and B is given 2, 6, 3, and C is given 3, 10, and -1. And we have to show that these points are collinear. So first we will find this vector AB. Okay, vector AB. So vector AB is equals to, by applying the formula, line joining the 2 points. So x2 minus x1 I cap means 2 minus 1 I cap. Okay, and 6 minus 2, that is 4 j cap, and 3 minus 7 minus 4 k cap. This is the, okay, and now find the magnitude of AB as well. So magnitude of AB is equals to root over of 1 plus 16 plus 16, 32 and 32, root over and 33. And now find BC. So BC means C minus B. So 3 minus 2, 3 minus 2 I cap. I am writing directly. 3 minus 2 means I cap. Okay, and 10, 10 minus 6, that is 4 J cap, and -1 minus 3 minus 4 K cap. Okay, and now find the magnitude of BC. So magnitude of BC, that is 1 plus 16 plus 16, that is root over of 33. And now find AC, the vector AC. The vector AC means C minus A, so 3 minus 1, 2 I cap, and 10 minus 2, that is 8 J cap, and -1 minus 7, that is minus 8 K cap. Okay, and so magnitude of AC is equals to 4 plus 64 plus 64, 128, 132. Okay, and 132 means 4th, 33 into 4 means twice of root over 33. Twice of root over 33. So it means that since magnitude of AC is equals to magnitude of AB plus magnitude of BC, because the sum of the magnitude of any two vector is equals to magnitude of third vectors. So therefore A, B, C are collinear. Okay, collinear. Okay, and the next question is question number 17. And the 17th question is, question. Question number 17th. And question number 17 says, show that the vectors 2 I cap minus j cap plus k cap and these vectors are form the vertices of right angle triangle. Again, the same type of questions. Anyhow, uh, so vectors are given vectors are uh, given vectors are, let vectors are position vectors ले लेता हूँ. Let OA is equals to 2I cap minus j cap and plus k cap. Okay, and second vector OB, this is given I cap minus 3j cap and minus 5k cap, and OC is 3I cap minus 4j cap and minus 5k cap. Okay, form a right angle triangle. So if it is right angle triangle, then we will find the side AB. Okay, AB, B minus A. So I minus 2I minus I cap, and minus 3 and plus 1, that is minus 2J cap, and minus 5 minus 1 minus 6K cap. Okay, and find the magnitude of AB as well. So magnitude of AB is equals to 1 plus 4 plus 36, that is root over of 41. And then find the magnitude of, okay, root over 41. Then find the magnitude of AB square also, because we have to show that it is a right angle triangle. So magnitude of AB square is equals to 41. Okay. Now after AB, find BC. So BC is equals to C minus B, 3 minus 1, that is 2I cap, minus 4 plus 3, that is minus 1J cap, minus 5 plus 5, that is 0K cap. So magnitude of BC is equals to 4 plus 1, that is root over 5. So magnitude of BC square is equals to 5. Okay. And now find AC. AC means C minus A. So 3 minus 2, that is I cap, and minus 4 plus 1 means minus 3J cap, and minus 5 and minus 1, that is minus 6K cap. So magnitude of AC, that is equals to 1 plus 9 plus 36, that is equals to root over 46. So magnitude of AC square is equals to 46. So 41 plus 5, 46. So since magnitude of AB square plus magnitude of BC square is coming to magnitude of AC square, so therefore triangle ABC is right triangle, and right triangle at which vertex? C vertex. Right angle at C. Okay, and the last question, that is question number 18. If A is a non-zero vector of magnitude A and lambda a non-zero scalar, then lambda A is unit vector if lambda A is means that should be equal to D part, A is equals to 1 by lambda. Okay, so this is all about your dot product or a scalar product. So if you are having any doubt, then don't forget to write in the comment section. Your comment is very valuable for me. Anyhow, thank you very much. If you like this my way of teaching, then please press the like button and share this among your friends. Thank you. Thank you very much. Now the hello students, again welcome back to Dr. Haider classes, and now we will take the rest of the exercise, that is cross product of two vectors. Okay, cross product of two vectors. Cross product of two vectors. Cross product of two vectors. So this is cross product, or we can call it vector or cross product. Okay. So for the cross product, it is A cross B. It is denoted by A cross B. And A cross B is equals to magnitude of A into magnitude of B sine theta n cap. Magnitude of A, magnitude of B sine theta n cap, where theta lies in between 0 to pi. as per the definition. Okay, so where theta is lying in between 0 and pi. Okay, so let me explain the some concept, then we will switch over to the exercise. So if vector A is 0 or vector B is 0, then of course their cross product. So this implies that because sine 0 will be 0, A is 0 means the whole result is 0. So A cross B is equals to 0. And when the cross product of two vectors are 0, it means that the vector A is parallel to vector B. Okay, so this is the difference between the dot product and cross product. If the dot product of two vectors are 0, then the vectors are perpendicular, and if the cross product of two vectors are 0, then the two vectors are parallel, and as well as vice versa. Vice versa means if we have to prove that the given two vectors are parallel, then there we will find their cross product, it should be equal to 0, or if it is given that two vectors are parallel, then the cross product is 0, and then we will simplify. Okay, now in the very particular cases, okay, A cross A is equals to 0, right? A cross A is equals to 0, and A cross minus A is also 0. Okay, now so where theta lies, where theta is 0 because sine 0 0 and theta is 0. Now we will take if theta is 0, then A cross B sine 0 0, this is 0. Okay, that we have already discussed. Anyhow, if theta is pi by 2, then A cross B is equals to magnitude of A into magnitude of B, because sine pi by 2, sine theta, sine pi by 2, that is 1. Okay, and then the cross product. Okay, so cross product means I cross I or J cross J or K cross K. Okay, in the same component, I cross I is equals to J cross J is equals to K cross K. In the cross product, it should be 0. In the dot product, it should be 1. I cross I or J cross J, J dot J, and K dot K is 1. But in the cross product, it is 0. And now, if we will go in cycle, suppose this is the I vector, and this is the J vector, and this is the K vector. Okay. So I cross J is equals to K. I cross J is equals to K, and J cross K is equals to I, and K cross I is equals to J. K cross I is equals to J. We will move on in the cycle, means in anti-clockwise direction. Okay. Now the angle between this. So the angle between this means sine theta is equals to A cross B upon magnitude of A into magnitude of B, to find the angle between the two given vectors in the case of cross product. Okay. In the case of cross product. Nothing more to explain. Then area of triangle, or otherwise if we will change the direction, if suppose the question is J cross I, then J cross I will be equal to minus K, the direction will change. And now the next thing is area of triangle. So area of triangle is equals to 1 by 2 and magnitude of A cross B, and area of parallelogram is equals to magnitude of A cross B. Okay. magnitude of A cross B, that is equals to area of parallelogram. Then again the same distributive property or commutative property we will apply now. Okay, so now switch over to the exercise 10.3.